Today we're going to review how to multiply and divide fractions and decimals. We're going to start off today with fractions, and I want to make a reminder that no common denominators are needed. If you do find common denominators, your answer will still be the same. You will just have to spend more time reducing at the end because your denominators and numerators will be very large. We're going to go ahead and start off today by multiplying fractions. When we multiply them, we multiply the numerators and then the denominators. What I would do is multiply 5 times 3 to get 15, 12 times 4 to get 48, and then what I would do is check to see if I can simplify. In order to simplify, I would list my greatest common factors, or GCF, for both 15 and 48. 15, the common factors are 1 and 15, and 3 and 5. Remember, factors are two numbers that multiply together to get a product. I'm going to go ahead and find the factors for 48. Factors of 48 are 1 and 48, 2 and 24, 3 and 16, 4 and 12, and then 6 and 8. What I noticed is that the greatest common factor is 3. So what I would do is I would divide both the numerator and denominator by 1, essentially keeping the fraction the same but changing the amount of pieces the fraction is cut up into. And 15 divided by 3 would be 5. 48 divided by 3 would be 16. This would be my simplified product. Now, some students use other strategies. They use a strategy where before they multiply, they simplify or reduce. I'm going to show you that strategy. 5 over 12 times 3 over 4. What students will do is that they'll look for a greatest common factor of each diagonal. So the greatest common factor of 3 and 12 is 3. What I would do is figure out how many times 3 goes into 3, and it's once. 3 goes into 12 4 times. Now what I would do is look at my other diagonal, 5 and 4. Unfortunately, 5 and 4 just have a common factor of 1. Then what I would do is go ahead and multiply numerator times numerator, which would be 5 times 1, which is 5. And then my denominator is 4 times 4, which is 16. I get the same product. 1, I multiply and then simplify to get my product. This strategy I reduced before I multiplied and got the same answer. Either strategy is fine. We're going to go ahead and use a strategy to now divide fractions. I'm going to multiply as well, so you're going to see me use this strategy here. When you divide fractions, what you want to do is keep the first fraction the same, 2/3. What you want to do is change the division symbol to a multiplication and then find the reciprocal of that second fraction. Reciprocal means that I'm going to switch and now make my numerator the denominator and my denominator the new numerator. The reason why that works is that when I look at this problem, if I cannot divide straight across, so for instance, if I had a fraction that said this, 15 over 3 divided by 5 over 3, I could divide straight across. 15 divided by 5 is 3. 3 divided by 3 is 1. That would be a legal strategy to divide. Well, unfortunately, 8 can't go into 2 an equal amount of times. So what I need to do is use a strategy called multiply by the reciprocal. The reason why that works is that I can do 15 times 1/3 to get 5, or I could do 15 divided by 3 to get 5. Here I'm dividing by 3. Here I'm multiplying by 3's reciprocal. So either strategy works. What I'm going to do is use the simplification strategy before I multiply, and I'm going to look at each diagonal. So 3 and 9 have a common factor of 3. 3 goes into 3 once, 3 goes into 9 3 times. Then what I'm going to do is look at the other diagonal. 2 and 8. 2 and 8 share a common factor of 2. 2 goes into 2 1 time, 2 goes into 8 4 times, and I'm going to multiply straight across. 1 times 3 is 3, 1 times 4 is 4. Here is my quotient. When I divide, my answer is a quotient of 3/4. Again, we took the dividend divided by the divisor. We had to use the strategy of keep the first fraction the same and multiply by the reciprocal because we could not divide straight across, and our answer is 3/4. Just to be aware that when we do work with fractions, sometimes we might have mixed numbers. So I want you to be aware when multiplying and dividing with mixed numbers, please convert to improper fraction first. What I did is I gave you a strategy here where A is the whole number and then B over C is the fraction. This whole thing is called a mixed number. What you would do is you would take the denominator times the whole number and then add together your numerator and then put it all over the denominator. So I gave you a strategy here with some numbers. So 4 times 3 is 12, plus 3 is 15, all over 4. If I don't know, again, another way to think about it is using a model. If I have 3 whole pieces cut into fourths, so again, 4 fourths, 4 fourths, and 4 fourths, this would be a total of 12 fourths. 12 divided by 4 is 3. And then here's the additional 3 fourths. So when I combine those together, the reason why it's legal to multiply the 4 times this 3 is because that's giving you 12 fourths, and then you would add it to the additional fraction that you have here in the mixed number, getting 15 fourths. What I'm going to show you next is strategies to multiply and divide our decimals down below. What I wanted to show you here is when you multiply decimals, you don't have to worry about any denominators or anything like that when it comes to fractions. All you're going to do is line up your numbers. You don't have to line up decimal places like you do when you add and subtract, but you're going to do 9 4/10, and then underneath I'm just going to fill in the numbers. Again, you do not need to line up the decimal places. What you want to do is you want to do the traditional algorithm. 8 times 4 is 32. Carry the 3. 9 times 8 is 70. Let's see here. 9 times 8, 72. Plus 3 is 75. I'm going to go ahead and bring down the 0 and then do 1 times 4, which is 4. 1 times 9, which is 9. Remember, we've already used that 3. And then I'm going to add together our place value columns. 2 plus 0 is 2. 5 plus 4 is 9. And then 9 and 7 is 16. Now here is the part that we need to remember. We do not carry the decimal place down. We don't line up the decimal places when we multiply. We actually count to see how many decimal places are to the right. I have 1 decimal place here and then 2 below in this problem to the right of the decimal. So therefore, I'm going to start here at the very far right-hand side of the number, and I'm going to move my decimal place 3 places to the left. 1, 2, 3. And my solution should be 1 and 692 thousandths. There's my product. Again, I count up those decimal places and then put my answer in the bottom. If you choose not to use this, you could always do 94 times 18, multiply that together, and in the problem, count how many decimal places you have to the right of the decimal and add them in at the end. Either strategy works great. So again, this is how you multiply decimals. Here is how you divide decimals. So the first number, just like when we divided fractions, is our dividend, and what we're dividing by is what we call our divisor. For this particular problem, we're going to have to use long division. Putting our dividend underneath that division bar, so 42 and 3/10, and we're going to put our divisor on the outside. Now when we divide decimals, we cannot have a divisor with a decimal. We have to move our decimal place, or in this case, we would have to change this to a 5, so I would have to move the decimal place so this outside number is a 5 or a whole number. And really what we did is that we multiplied this by 10. So if I move that decimal place 1 to the right here, then I would have to do the same thing with the dividend. The reason why we have to do the same to both numbers is so we don't change the value of the numbers or vary the problem. We're just making it easier for us. I'm going to write 423 right underneath for my dividend. Now I'm going to go ahead and do our long division. Remember, we're going to divide, multiply, subtract, and then bring down. So we're going to divide first. 5 doesn't go into 4, but 5 goes into 42, and it goes into 42 8 times. We're going to multiply next. 8 times 5 is 40, and then we're going to subtract. 42 minus 40 is 2. Then we're going to go ahead and bring down the next number in our dividend to make that 23. Then we're going to start this process all over again. So we're going to figure out now how many times 5 goes into 23. Now 5 goes into 23 4 times. We're going to multiply 4 times 5, which is 20, and then we're going to subtract 23 minus 20 is 3, and then we're going to bring down. Now, unfortunately, I've run out of numbers in my dividend, so in Visible Math, really the decimal in 423 is to the very far right-hand side of the number, and I'm going to place a 0 there, as many zeros as I need. I'm going to go ahead and bring that 0 down, and sure enough, when I do this process again, 5 goes into 30 6 times. 6 times 5 is 30. Oops, I ran out, and when I subtract, I get 0. No remainder left. So in this process, we have to figure out now, where does my decimal go? Well, when you divide decimals, all you're going to do is bring that decimal place straight up into the quotient, and your final answer should be 84 6/10. Now, I'm going to pull this down just really quickly, and we're going to talk a little bit about how our integer rules pop in. So we are not only going to be multiplying and dividing fractions and decimals, but we're going to be adding in our integers. So what happens if I make both of these negative? So if I have a negative 5/12 and a negative 3/4, remember, anytime we have a negative times a negative, our answer would be positive down below. Let's say we look at these fractions. If I had a negative 2/3 and I divided it by 8/9, just so you know, if this was negative and I divide it by a positive, my answer would always be negative, and I'm using our integer rules. Do you notice here how the only thing that I added are just the symbols? All the mathematics are the same process as what we did without having any of them be negative. Let's go down here to our decimals. Remember, when I have, let's say I had this number as positive and that 18/100 was negative. Anytime I multiply a positive times a negative, my final product should be negative. And I'm just going to review that same thing here. When I divide a negative by a negative, my answer should be positive. Please make sure you pause. Make sure you write down all the steps that you needed today. And when you are ready, please go ahead and shut off your computer. Make sure your notes are still out, and look to the front for our activity.